this problem, move pieces to obtain a string. So you are given two strings, start and target, both of length n. So there are two strings are given to us and they are of same length, and each string consists of only capital L, R and underscore. Only these three characters would be there. So there are two operations. What we can do is, if the character is L, okay, and R represents the pieces. So basically it would be something like this, that if character is L and there is left side underscore, then L can move to left side. Similarly for R, if there is a underscore on the right side of it, then this R can move to the right side. So this is the operation we can do. So what we have to do is, using this operation, we have to make this operation on the string start, and we have to achieve the target string. This is what we have to do. So let's take one example for a better understanding. So suppose we are given these two strings. Okay, this is our start string and this is our target. So what we have to do is, using our operation on the start string, we have to achieve this target. Okay, so see what we can do is, L is on leftmost, right? So this is L. So is there any blank underscore? Yes. So we can move this L to this place, right? So if I move this L here, this will become like this, right? All other things would be like this. Now we are at here, R. So we need R together. So because there is a place on the right side, because R can move only to right side if there is a blank on the right of it. L can move to the left side only if there is a underscore to the left of it. So here R, there is a underscore to the right side of it. So this R can move here, right? So this will become now, this extra space will come here, and then this R would be there, and this R would be as it is, and then underscore. Now we can do one more operation here. So see here, this R can be moved here, and this R then can come to its place, right? So what would be the resultant thing? Resultant would be L is as it is, underscore 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 underscore, and this R we are moving to this place. So this R would be coming to here, and then the one place would be empty, then this R would be come to its place. So this R will come in here, and one more place we have found. So what we can do is, finally we have found the same string as target, right? So you remember that L can move to only left, and that also only when there is a underscore to the left side of it. Similarly for R can move only to right if there is a underscore to the right side of it. Okay, so this is what we have to do. Now next thing is how to do this. Okay, how to do this. So we'll think about this. So guys, you can observe one thing here. You would have been observing here that R and L cannot be cross each other, right? Let's say if string is something like L underscore underscore R, and we have another string something like this, R underscore underscore L and underscore. So see here, even we do whatever operation, we just cannot come into this way, right? L and R cannot cross each other, right? So this would be never achievable, because the relative position of L and R are the different in the target string. Okay, so the answer would be only achievable when the relative position of L and R are the same in both string start and the target. We have observed this thing. If their relative positions are not correct, then they will never be achievable. See here, we do whatever operation, we can never achieve this thing, right? Because we can never cross L and R, right? So this would be never achievable. So relative positions are the one thing, and one more thing is there. So let me come up with an example itself. So guys, you can have look at here. Start is this string and target is this string. So you can observe here, even the relative positions are correct, right? RLR, RLR, but still this would not be achievable. Why? Because if you look, let's say we can even consider if it is like this, their length of same, right? 1 2 3 4 5 6 7 8 and 4. Okay, yeah. So let's say I'm making one underscore here. Still this would not be achievable, because you see here, this R can go only to right side, right? This R only can go to right side, right? Or can stay on its position. But see here, if we go to right side, we will make further RL, right? So there is no possibility we go to the right side, there is no fruitful result will come to us, because anyway we need the two space between R and L. But because R cannot move to the left side, R can only move to right side. So in this case you would have observed one thing, that if in target position the position of R should not be the index position. Let's say here index position, what it is sitting at index 1, right? This is 0 index, this is 1 index. But in start, what is the index here? This is 0, 1 and 2. So now you can observe that index of this R in the target should not be smaller than the index of the R in the start position. You would have observed one thing. Okay, and similarly for the L as well. Okay, so I will take a different example. So now you should be clear that either the index of R should be equal, or the index of R should not be the this, like in this case index of R is 1 and index of R here is 2. So it should not be like smaller, it should be greater, then only it would be possible. So in this case it would be false. You would have been very clear, because of the R index is smaller, so it would never possible. Similarly, we can take the example for the L as well. So let me take a different example. So for example, this time our start is like this and our target is like this. So if we compare here, this is fine, right? This portion is fine. This is underscore L, this is also underscore L. So we don't have to do any operation so far. But see here, there are two spaces here, but here is only one space. But L cannot move further to the left. L can move to the only one place to the left side, right? But here this L is at a distant place. So you can say here, if the position of L are same, then it should be not a problem. Like this is at also index 1, this is also index 1. But see here, this guy is at index 3, right? It is at index 3, and but this L is at index 4, right? So here we can clearly say that in target, the index of the L should not be greater than the index of the start. Otherwise, that also will never be possible, because left have only the option to decrease its index, it cannot increase, correct? Because it can go to only left side. So this is scenario of L. So what we have to do now, we found the three things. Number one is their order should be same, right? Order should be same, that is number one. Ordering of the L and R should be same, basically the relative positions. Then we found for the position R, okay, so this R should be either at the same location, or it should be a smaller one, right? And similarly for L, this scenario, right, L should never be the greater than the L of this, because L can only further decrease its index. So these three conditions we have to take care. If we are not getting caught, then our things would be fine, right? So this is what we have to do. So how we will do in our code, let me show you my code for this. So we come here. So what we will do is, suppose this is our start, this is string, and this is target. So we have taken two pointers, string, that start pointer and target pointer. Let's say these are two indexes, initially 0 0. So we started here. So wherever it is underscore, we are ignoring. So this is underscore, so we will increase it, so it will become 1. Here also this is underscore, we will increase it, this will become 1. Okay, now this is L, right? So L and L, so we are coming here, both of them are same, right? So we are also looking here for the this thing, you know, the ordering of them. So ordering also should be same. So anyway, this is L and this is also L, so we are good. We can again go to the next pointer. So this is underscore, and here also this is underscore. So anyway, we will increase it. So this would become now 2. This also would become now 2. Okay, now we are coming here. So for this thing, underscore, right? So we will increase it, so this will become 3, right? But when we are coming here, it is L, right? So we would be at L. So at L we will check that what is the index here. So at L it would become 3, right? So what was the position of L in this original one? Okay, so when we will keep on going, we will stop here. Like once we got L or R, we will wait for till the time. So we were going, first of all we came here, so 0 1 2, it become till here 2, then it came 3. So at 3 it is L, and when it came 0 1 2 3, so here also it is L. Okay, so it was fine till here 0 1 2 and 0 1 2 3, yeah. So at 3 we stopped here, because whenever we are getting L and R, we have to stop so that we can compare. So we are at here 3. So at 3 also it is L only. So char at 3 is L for the first string. Similarly, it is L for the second string. So we are good, right? If it were different, then we would have immediately written false, because our ordering would be killed then. So now this is fine. We are at the same page. Nothing is going wrong. So we will go to the proceed ahead for the next one. So what is the next? So next is underscore here. So we will make it 4, right? Next is also, this also underscore. So we will make it 5, right? Then we will go to this guy. This is R. So this is at 6. So at 6 we would be wait, right? Anyway, this is stopped in this. So we will wait here 6. So now we will go here. So what is this? This is underscore. So this also would be increased. So now this would become 4. Right, then we'll go to the next guy. This is R, so this will become 5. Now we will stop here. Whenever we are getting R and L, then we have to check that, hey, what is at 6? So in first string, what is at 6? It is R only. So we are at here, it is R. Then we have to check at 5. This also R. So that means we are still good. Our ordering is going good. Even the index are different, but ordering is going good. So here it is finished, right? We are done till here. Now we are coming here. So if we go next here, this is underscore only, right? So for underscore we were increasing, so this would become 6. So anyway, we are coming out of both of them, right? So whenever we are going in this way, if we found that any one of them reached till here, this will end up, right? So we will check whether they have what is the index here. So when we are keep on going, we keep on increase, right? So at the end it would be stopped, because anyway our length is only up to here 7, right? So total length is 7, so it would be stopped. So final value is this index would be 7 at the time of stoppage, right? And similarly, so at any time if the length of this guy is 7, that means the other guy also should be finished, correct? Because if any one of them is reached till the end, and if they are matched, then this also should be reached till the end, right? Because there were underscores, so this also was keep on going. So both of them came out with the value 7 and 7, right? So any one which is reached, that means other guy also should be reached if they have to become equal. Otherwise we have to return the false. So whenever this guy first reached end, right? So our this guy also, both of them should be reached the end. Otherwise there would be of the different length or different ordering would be somewhere. So that is first priority. Then we have to look for the other cases we were checking. This is one of the favorite case. We have to look for the L and R positioning as well. So let me take a different example. Or we can consider this example itself. So for example, let's say this was R. Okay, this was something like LR, and this is LL only. So what would happen at this location 3 when we compared, right? This guy would be R, right? Here it would have become R, but here in the other guy it was L. So when we found a mismatch at this location, then we would have written directly false, because this would not be possible, because as we know that R and L, if they are of different type, they cannot pass through the operation. Okay, so whenever we find any violation, we would have written directly false in that position, as we have already observed that the R and L positions accordingly. We took the two examples, right? So that way we have to do. So let me show you my corresponding code for it. So see here, these are my two pointers. These are the length of it, and we have start index and target index. So see here, what we are doing is, while they are less than their respective lengths, what we are doing, we are ignoring here the underscores, right? We are keep on increasing for the start index, similarly for the target index whenever there is encountering of the underscore, and then we are keep on going. So see here, if any one of them is reached to the length, right, start index, let's say reach to the length of it, in that case what we were doing is like uh, if they are one of them is reached the other till the length, then other also should be reached till the length, then only it would be returning true, otherwise it would be false obviously. Then we have another check, we check, right, for L and let's say, so see here in the start, so if it is L, okay, this is the L at start index, and this start index is basically lesser than the target index, in that case also we were returning false, right, because in our target index this cannot go greater than the start index. In case of this is L, we just so, and similarly for the this thing as well, if you check here, if characters are not same, just we checked here, right, we did for here at this position 3, it was R and this was L, they were not same, and if they are not same, then also we have to return the false immediately. So same way, and this is the one more condition is like if at start index it is R, but this index is basically greater than the corresponding target index even when both of them are R, so then also this would be a condition to the false. So these three conditions if we are finding, then we have to return false, okay, and we will keep on increasing our start index and end index, and if we are not falling to any of these false or conditions, anyway we have to return it true. So this is what we have to do. Let me execute my code. So I am executing it, let me try to submit it. Yeah, so it is accepted. So thank you for watching this video, and we are taking O of n time complexity, and we are not taking any extra space. So thank you for watching this video. If you guys have any concern, please make a comment over there. Thank you.